Yeah, hello viewers wherever you are, and welcome to another edition of Chemistry on Fozana channel. And after some few days of break, we are back once again, and God willing, today we are going to look at one last example from the Mole and Avogadros before we proceed to the next topic in our next video, which is the molar mass. So we're still on the Mole and Avogadros constant, the Mole and Avogadros constant. That's the third video on it. So we are going to take an example from that topic for that matter. We are going to take one example from that topic. We are going to take an example from that topic. And the example is calculate the number of molecules. Question: calculate the number of molecules. Calculate the number of molecules in 0.6 moles, 0.6 mole of H2S. So this is the question that we are going to tackle in this video, and is, I think, one of the examples that we are going to tackle before we proceed to the next topic, maybe probably in the next video. Calculate the number of molecules in 0.6 moles of H2S. And I think this is a straightforward question. Anyway, I'll do that and do the last one before we go. So, solution, number of molecules is equals to amount of substance times L being the Avogadro's constant. L being the Avogadro's constant. So it's clear here that you've been given 0.6 moles. So 0.6 moles times 6.02 times 10 to the exponent 23 molecules per mole. So you are going to get 3.612 times 10 to the exponent 23 molecules. So this is what you are going to get. It's straight away. I wanted to do a different question, but I had to chance up on this one. But what I mean is, I shouldn't have bring this question. But be that as it may, this is a straightforward cut to it. So we are going to do the next one. This is a straightforward question. So I think I'll clean it so that those of you who think it's gone too so fast, you repeat the video and practice it accordingly. So let me go to the next one. So the next one is calculate the number of atoms present in, calculate the number of atoms of H and S of hydrogen and sulfur present in H2S. In H2S, remember we have hydrogen and sulfur. Those are the two elements that we have. They are the constituents of hydrogen sulfide. And so we are going to calculate the number of atoms of H and S present in 0.6 moles H2S. That is the question. So this is the question that I wanted to write to start with, and not the other question that I wrote. That one anyway is straightforward, and we've dealt with it anyway. So let's do this one, and let's do this one. This is my focus. That is what I want our attention to go to. So we are going to get the solution. Our solution, you see that H2S as a compound produces what? 2 atoms of H and then 1 atom of sulfur. So if you can see that. Hence, when you have 1 mole here, it automatically translates into 2 moles here, and then 1 mole here. 1 mole here. Those of you who are familiar with the chemical equation and relationship and how to drive the relationship. So check this one before I continue, because this is 2 atoms of hydrogen. That's the 2 hydrogen atoms and then 1 sulfur. And then if in the equation you have 0.6 moles present in H2S, it means we have 0.6 moles here. In terms of the hydrogen, we have the same, because this is 1 mole is to 2 mole. It means we have twice of this here, 2 times 0.6 mole. You see, relationship of equation, if 1 mole of H2S produces 2 moles of hydrogen atom and then produces 1 mole of sulfur atom, 1 mole. So hence we have, if 1 is to 1 for sulfur, hence we also have 0.6 moles of sulfur. 0.6 moles of sulfur. And when we are to calculate the number of atoms of hydrogen, the number of atoms of hydrogen therefore is N is equals to the amount times the Avogadro, and the amount is this one. So we have 2 times 0.6 mole times 6.02 times 10 to the exponent 23 per mole, atoms per mole. Atoms per mole. Hence you have 7.224 times 10 to the exponent 23 atoms of hydrogen. So that is the atoms of hydrogen we have there. If 1 is to twice of that, so hence we have that. And in the same way, okay, let me give you some few seconds before I finalize the last answer and end this video. I want to start a fresh video on the new topic. That's why I want to close a chapter on the Mole and Avogadro's constant. That's part 3. That is part 3 of the videos we are doing. You know, this is part 3. So let me finalize the last part, the last solution. The last solution. So judging from the relationship, you can see that the number of sulfur atoms is what? Still amount sulfur atoms times the Avogadro's constant. And the amount of sulfur atoms is what? 0.6 mole times 6.02 times 10 to the exponent 23 atoms per mole. Hence we have what? Half of this one, which is 3.612 times 10 to the exponent 23 sulfur atoms. So that is the answer we have there. That is the answer we have there. And then I think with this one I'll bring an end to the Mole and Avogadro's constant. That's the part 3 of it. hence the third one, because I'm bringing it to an end, because we've almost look at all the scenarios, and so if you viewers at home will try to solve any question in it, the method and applicability is very clear for you to try and solve it effectively. Thank you very much. Thank you very much for joining me on this video. Please, if this is your first time of subscribing to the channel, do well to hit the subscribe button as well as the notification bell, and share to a greater number of students who also benefit from these classes. Thank you for joining me on this program, this video. God richly bless you, and cheers.